We know that percent equations involve three quantities, one called the percent, another called the base, and another called the amount. In the last two sections, we have solved for the amount and the percent. So here's our percent equation. We've solved for the amount, for the percent in the last two sections. Now we're going to look at problems that involve the base as the unknown quantity. Those problems often take a form like this. 18% of what quantity is 900? And as we've seen before, we interpret this sentence into a mathematical form, into an equation, and then we solve the equation. And that's pretty much the basic concept for approaching all of these problems. 18% we'll write as a decimal. We slide the decimal point over, and this becomes 1800ths. Of means times. What means what number. Now, I can write a little times sign here, or I can just put the letter next to the 1800ths, and it means the same thing. If I put the n right here, it means the same thing as times n. All right, is means is equal to 900. And now, to isolate the n, to solve this, we want to isolate n. To isolate n, we need to remove that 1800ths, and to do that, we found in the past that we divide on both sides by that number. And so we'll show that the left side is divided by 1800ths, and the right side is divided by 1800ths. These go out, and we find n to be whatever quotient this is. Now, I want to emphasize that we're going to show the division here in just a second, but I want to emphasize that we want to show all of these steps in getting an answer to these problems. And I know that I've mentioned it before, but I can't mention it too many times as to how important it is to maintain the integrity of the equation situation, because problems become more and more difficult. And in my way of thinking, it's more important to show the various steps involved in the equation and the solving of the equation than it is to find a correct answer, indeed. Because problems get more complicated, and we need to know the general idea in solving certain kinds of problems. We need practice on the simpler problems in order to be able to handle the more difficult ones. So please pay attention to that idea. And as you go along, also I encourage you to amplify your penmanship skills, to show the organization in a very neat way. That cuts down on the amount of thinking that you have to do in the whole process. All right, we have a quotient here, 900 divided by 1800ths, so it's 1800ths into 900. Now let's see how this goes. We say that we can only divide by whole numbers in order to place the decimal properly into the answer, and this decimal point slides 2 over, and therefore the decimal that's understood to be here will need to slide 2 over. So we'll need a couple of placeholders there, and the decimal then goes straight up into the answer. When we divide, though, notice that 18 into 90 goes 5 times. 5 times 8, 40, right? The 0 carry the 4. 5 times 1, 5, and 4, 9. Oh, this seems to go evenly. See, when we subtract, we get no remainder here, and our prescription for division is to bring down the next digit and divide. Well, 18 goes into 0 no times. Now, we can say that 18 goes into 0 0 times because 0 times 18 is 0. Something like that, you see, and then bring down the next digit and go through the same process. Or we can say, well, gee, we know that we're going to get zeros down here, and all we have to do is fill the positions between this digit 5 and the decimal point. And if we have things lined up pretty well, we know that we need to fill those positions with 3 zeros. Okay, so 5,000 turns out to be the quotient, and n then is 5,000, and we are answering the question posed, where we're saying then that 18% of 5,000 is 900. Here's another one, same idea. 125% of what number is 32? 125% changes to 1.25. Of means times, what means what number. So 1.25 letter is equal to 32. Now to isolate the n, we show the division of 1.25 on both sides. We bring down the left side, divide by 1.25. Bring down the right side, divide by 1.25. These cancel as expected, and now we have a division to perform. Once again, we can go out to the side. Maybe we'll use a calculator, but we'll find that it's 25.6. So 25.6 answers this question. 125% of 25.6 is 32. This one says 30 is 2.5% of what? Now notice that we're kind of changing sides of the verb here in our statement. That is, our percent and base are on the right side of the verb in this case. No big deal, as we have seen before. We interpret the same way that we normally do. That is, bring down 30. Is means is equal to. And 2.5% changes to a decimal. Of means times. What means what letter. You see? And so to solve, we divide on both sides by the number next to the letter. And we're dividing on both sides by 0.025, and we show that step. And these can cancel, leaving x. And on the left side, 30 divided by this decimal turns out to be 1,200. Here's a problem in which it's more convenient to change the percent into a fraction than it is into a decimal. And this is a little bit of an unusual situation, but it comes up from time to time. And if you if you realize that when percents are expressed using a fraction, we change the whole percent into a fraction. I think that's a good rule of thumb. So here, when we come into the next step where we say 72 is equal to, and then we come to 66 2/3%, we think, well, gee, let's change this into another form, and it can be changed into a decimal or a fraction. We're going to elect to choose the fraction form because we see a fraction in this percent business. Now, we have to remember how that process worked. Let's come out to the side and think about that a little bit. Remember that percent means hundredths, and we multiplied by 1/100th in order to accomplish the change. So what we have here is 66 2/3%. And recall that we think of this as 66 2/3 times 1/100. So that's the idea. Percent means hundredths. Now we multiply. Let's see, 3 times 66 turns out to be 198, plus 2 is 200. So we have 200 over 3 times 1/100. The 100 and 200 can cancel. 100 into 100 goes one time. 100 into 200 goes two times. Multiplying straight across, 2 times 1 is 2. 3 times 1 is 3. So 66 2/3% is 2/3. Let's come back over here and pop that in. So we have 2/3 of means times. What means what amount? So we'll let a letter stand in. Now there are actually several techniques that are possible to clear the 2/3 from the right side in this situation. But we can follow the technique that we are already accustomed to. That is, we can divide on both sides by the number. The number's a fraction here, but no matter. We can divide on both sides by the number next to the letter in order to remove it. So we're thinking this way. We're taking the left side and we're going to divide by 2/3. Now I'm going to write the fraction. Usually I don't write fraction bars with a slanted little fraction bar like this, but I'm going to do so here because of that. The fraction bar that's already in place. And on the right, a similar idea. This is 2/3 in the numerator, and we're dividing by 2/3. You see, and these cancel. And on the left side, we need to interpret this situation. This is 72 divided by 2/3. Well, we're a little more accustomed to seeing the situation like this. Let's slide over this way. It's 72 divided by 2/3. And if we write it like this, we know how to take care of it. This is 72 over 1 times, remember, we change the sign to times, and then flip this over. 3 over 2. We have a cancellation opportunity with the 2 and the 32. 2 into 2, 1. 2 into 72 is 36. Now we have 36 times 3. Well, 3 times 6 is 18. Carry 1. 3 times 3, 9, and 1, 10. So this is 108. We slide back over here, and we find the value of n is 108, and we are answering the question. 72 is 66 2/3% of 108. Redwood City has a population of 42,000. This is 75% of the population 5 years ago. What was the city's population 5 years ago? Look at the middle sentence. It says this is 75% of the population 5 years ago. What I know about this sentence is that is going to mean equals. All right, now what about what's on the left side of the equal sign, the this idea? What does this refer to? Well, it refers to information in the previous sentence. It says, it refers to that population of 42,000. So the this in the second sentence really is 42,000. 42,000 is 75% of the population 5 years ago, you see. Then on the right side of the equal sign, 75% is 75 hundredths. Of means times. And the population 5 years ago is what we're looking for. So we let a letter stand in for that amount. Now we'll solve by dividing on both sides by the number next to the letter. So we're dividing by 75 hundredths on both sides. And on the right we get a nice cancellation as expected. On the left, when we perform the division, we get 56,000. So the answer to the question is the city's population 5 years ago was 56,000.